So, as I understand, there was some interest in storage arrangements, especially to rubber, storage, tire storage. But I will start first with an overview of storage arrangement with the sprinkler, how the sprinkler has developed for storages. And then I will come later to the fire, and we can discuss it in detail. So, in general, I have a presentation more for either designers or distributors. So, but this is for consultants and distributors. With more detail. So it's not so graphic. This is more detailed.
So this is just an overview.
Yeah.
Later you will more discuss about the design of
Okay. And we can talk about the PA and FM for storage of fires.
That's good.
Okay, let's start. Myself, Robert Gelman, almost 20 years in the business. This year will be the 20th. I started as a project manager for sprinkler, and then I did design management. I did that for 9 years. And then I went for the consulting business for 6 years, doing inspections, investigation, commissioning systems, testing, full-scale testing like that. So, and then I started to work for IKEA.
IKEA?
Yeah. As a fire risk manager for IKEA Russia. So I worked in Moscow for 5 years. So, and then my contract ended, and then Tyco told me that if I wanted to start working in Singapore.
So you're based in Singapore?
Yeah.
Okay.
But my wife and me lives in Jakarta.
Oh,
For the moment. But we will move over to Singapore later.
Okay.
Just to start up, so I can start working and she can do the family stuff.
Okay.
So now I'm business development manager for Southeast Asia in India, and it's motor products, mostly sprinklers. So here you have my mail address and my phone number. If you have any future, I don't have so many cards. I don't give it to.
Okay.
I give you.
I think any question about the design of the product, you can just
Forward to.
I mean, whoever gets my question, put it here and you
Probably if there's a question, we will go to our engineer.
okay.
So not too much people.
Yeah.
So we have one channel.
Yeah, one channel. Not confusing.
Yeah, otherwise it can be confusing sometimes. Yeah. So I will talk about the evolution of storage versus sprinkler and challenges for property owners and user insurance companies. Sprinkler storage, trends, presentation, and also for the future, how the future looks like.
Kalau ada yang kira-kira jelas langsung akan tanya. Ya.
Tell me if you need translation. So.
Yeah. I will try.
Yeah.
See how we can.
Yeah. It's very good. Yeah. It will not be so much text. I will talk instead, so you don't need to read. So listen to me, and then of course you can read it. So I will start with the fire test. This is a test for ESFR sprinkler, IKEA test. So you can see the fire in the bottom of the racking. This is a test for IKEA at FM 2000, I think it was made.
This is FM Global.
Yeah. So you can see how fast the fire is growing inside the rack. It's a lot of air and combustibles. 30 seconds to 10 meters to the roof approximately. 35 seconds, something.
difference the other sectors for the operation? Two sectors by smoke is being driven down, flames only
Yeah,
visible in
it's
the,
not so much more to see, but
Yeah.
what I wanted to show that is inside the
Very
axe, it's very fast.
Okay.
Then it's just a lot of smoke, so you will not see so much.
Jadi tujuannya ini menampilkan ini biar punya gambaran kalau kebakaran di rak itu sangat cepat sekali. Dalam waktu 1 menit sudah habis semua. Jadi intinya kita harus mendesain untuk storage itu benar-benar ada sprinkler khusus nanti dalam hal ini. Oke?
So, how did we get to where we are today? So I will talk a little bit about the history and how the sprinkler history came. So, this is a normal sprinkler, and that's what we were using very early. The new modern sprinkler was developed 53, the standard spray sprinkler. And before that it was the old conventional style, where you had water also coming up to the roof, so it was more like a ball. So 40% going up, 60% going down, so it was like a ball. And then they developed the spray sprinkler, so it's more like 95% is going down on the floor, wetting the area where the fire is. And going back to the storage arrangement, FM did testing in racking between 68 and 72, where they could see that it was before that really the end user could see that normal roof sprinkler was not enough for controlling the fires inside the storage. But at that time they had only like 4.5 meters of storage maximum. At best maximum. Yeah.
So the function of the sprinkler is only to control the fire, right?
Yeah, and the spray sprinkler is a control mode sprinkler. I will come back to that later. So what they did during this test between 68 and 72 was showing that to have only a sprinkler in the roof was not sufficient. With this is the K80 sprinkler. So it's not so much water that can come out of it. So what they showed it was inflexibility, it could not control the fire. So they started to thinking we need to do something else.
Okay. Jadi tadi yang sprinkler yang ditunjukkan itu adalah sprinkler normal yang ada sehari-hari di gedung-gedung itu. Jadi khusus untuk pabrik karena ceiling itu sangat tinggi, maka ini sangat sekali kurang. Maka dari bilang enggak flexibility. Jadi perlu sesuatu yang lebih hebat gitu lah. Nah ini akan ditunjukkan.
So now I will talk in a graph, not so much about text like that. So I will show you here how K-factor have changed storage heights, commodities inside the storage area during the time from 53. So we start with the storage height. This has changed. Row height has changed. K-factor and commodity classes. So we can see that if you set this red line, it's not really a science, but it's just to show you that what has happened. You can see that the commodity classes has really changed during the 1950s. In that time it was not so much plastic, what we have today. So what we had then, and then we have a division, mid-80s, end 80s, I will show you later. So on the left side we have the control mode design area sprinklers, this CMDA. And then you have control mode application sprinklers, specific areas. And then here at 53 we have the modern sprinkler. Then you have storage heights, 4.5, and roof height around 6 meters. And then you have a K factor of 8. What happened after this FM test is that you need to have more water on the fires. So they invented the K150 sprinkler. And that solved the problem for a small while. And then in the 60s and the 70s, the roof height started to get up on the storage because the land prices started to rise. So they needed to go higher.
Is this you mean this is the year?
Yeah, and the timeline is
year.
yeah,
Jadi pada
year.
tahun 1953 itu kan sprinklernya yang
Ya.
normal yang dari dulu.
Itu tahu ya bahwa itu perkembangan sprinkler itu dari tahun ke tahun, tahun 63,
dari
tahun 60,
1953
tahun 70, tahun 80.
sampai 80-an dulu masih dipakai yang ini
yang profesional.
Karena tingginya itu tinggi gudangnya tingginya
Sampai 4
ya baru 4
meter.
kemudian diciptakan lagi Pak,
Yeah.
sampai 2.
The biggest K factor is the more water.
Yeah, that's a simple equation.
Yeah.
So anyway, so in the 60s and 70s they did more testing, and then in the or 70, 80 they invented this ELO sprinkler. It's called extra large orifices. So they get up from K factor 115 to K 106, and the roof height now is 9 meters at that time, and the storage height is maximum 6 meters. So
The roof is meaning the ceiling.
ceiling, ceiling of the storage.
Storage height itu bukan barang.
I try to do it more logical. If you see on the left side, you have storage height in black, roof height in blue, K factor. I was not consistent there, I would say. I need to change that. And the commodity classes. I will put that as a reminder to myself.
Storage head itu adalah tinggi rak barang ya, tinggi rak barang. Kalau roof itu adalah tinggi ceiling atapnya. Itu K itu adalah sprinkler K faktor. K faktor yang makin besar, maka itunya makin banyak airnya, efisien lebih besar.
So, what happened next? So in the mid-80s, they came up with a bigger orifices, or bigger K factor, called large drop sprinkler. It's also a storage sprinkler. This, now we're talking about more or less to control mode specific application. So, instead of control mode design area, different approach how you design the sprinkler systems. But also then in the 80s we could see a big change in the commodity classes. From the beginning of the 50s to the 80s we have started increasing to have more plastic in everything. So suddenly they needed to do something else. Or when you have more plastic, it's more fire load. So it's more, instead in the 50s, everything was in wood, steel, maybe it's very slippery plastic. So now everything starts to develop by plastic commodities. So on the right side here, on the dashed line, you can see that they were experimenting with a different approach of sprinkler. So then they came up with the concept of ESFR. It stands for Early Suppression Fast Response. Early Suppression Fast Response. So on the left side we have control mode sprinkler. I will show you later about the difference. So what they invented was a sprinkler called ESFR sprinkler, and they started with a K factor of 200. They call it K14, or ESFR1. They call it also. It depends on. So now the roof height, it's almost the same, but the storage height is higher. And this was they started to investigate or develop this sprinkler in the mid-80s. So it took them a long time to make it. And then you can see during the years the K factor has just grown and grown, and here is where we are today. We have storage height up to 12.2 and storage or roof heights up to 13.7. And that is without in-rack sprinkler.
Tanya. Itu kalau dari K56, K8, K11 itu kan masih pakai alkohol.
Apa ya?
Pakai alkohol ya untuk pemisunya.
Alatnya.
14 ke ya raksa
Ya.
14 ke atas itu kan pemicunya pakai apa ya?
Itu sejenis metal. The conventional type, the dark glass is inside is the alcohol, but the new one is
Yeah, it's metal. Yeah, as you call it. I can't really find the word in English, but it's a bimetal.
So it's hot, then it will
Melts. It's two plates. It's glued together by small, like a pen or something. Yeah, and then when it gets warm, they disappear and then they open up.
Jadi bukan pakai bak lagi, dia itu sejenis baja, tapi sangat sensitif terhadap panas. Begitu panas sampai situ, dia akan copot meleleh.
The big difference between the bulb is they have different colors, but it's the same fluid inside. It depends just how big the bubble is inside. So when the element or the bulb gets warmer, the fluid expands, and when it's reaching the limits where it explodes, then it's
The
just
bigger bubble is a lower temperature.
I think it's higher.
The bigger bubble is higher.
Yeah, but then you can expand more.
Okay.
Terus kalau K14 dalam kurung K200 itu artinya apa ya? K-faktor.
Ya, itu kapasitor tulisannya itu. Karakteristiknya aja. Itu hanya karakteristik nanti akan dikasih.
So where we're heading? Yeah, I think we are heading for higher roof heights, higher storage heights, and bigger K factors. Because land is not cheap,
Ya.
so they build on height. So that is the future. Next one. Now I will talk a little bit difference between the control mode area density sprinkler and the ESFR sprinkler. Just to show you, this is the curve is not science, it's just a common picture. Here the fire starts, you have the heat release and time, so normally the fire is exponential. And what happens when you have a control mode area density sprinkler is that you cut off the heat release and you control the fire before you will have critical situation in the area where you are. So it will control the fire. That is the thing. So, but normally if you have a fire in this area and you have a sprinkler, the fire load is small, and there's only one sprinkler that release, so you will extinguish it anyway. But it's designed for a bigger area. So the difference when you have a suppression mode is that you suppress the fire and the heat release and extinguish the fire. So that's the big difference between a control mode area density sprinkler or a control mode specific application.
Tadi di depan dia dijelaskan ya, ada sprinkler yang sebelah kiri itu ada kontrol. Jadi kontrol itu maksudnya itu kalau ada kebakaran, dia hanya meredam saja, dia nggak bisa matiin api. Tapi apinya tidak berkembang. Jadi tetap dikontrol supaya menunggu bantuan datang pemadam kebakaran atau ulang firefighting. Kalau ini yang suppression mode, dia bisa menekan sampai memadamkan. Jadi dua jenis sprinkler yang berbeda. Ya.
So what they are playing with is also if you thought about the previous text or this one between the left side on the right side of the dashed line, ESFR. When they started developing the ESFR, they were playing with the response time index, how fast the sprinkler was, because what they're thinking is that you need to have an early detection to suppress the fire when it's still small, and also to work with this ADD and RDD, as they call it. Required delivery density and actually density delivered to the space. So they were playing with three different in the equation. So RTA, RTI factors, and the RDD and ADD. So they were playing with this, and then they come up with a suppression splinter. So now we go to chapter 2, and that's challenges for the property owners and users, and also insurance companies. This is what we're going for. You can see the strength is getting higher, larger. Storage, commodities, more plastic. The end user want to have flexible solutions, storage solutions. They don't want to have index sprinklers, because then they get stuck.
Not flexible.
Not flexible to change
the rag and more right.
Yeah. And then of course to have the correct sprinkler design. But it's very hard. Sometimes it's very hard to do that. And of course, if they have a fire, they will have business interruption. Costly, very costly can be. I can make a small example from the end of 90s, I think. It was when Ericsson and Nokia was the big key players for the phone industry. Then they had a production. Ericsson had a production facility in Mexico for producing the chip for the telephone. And they have a big fire there. And no sprinkler. No sprinkler. Yeah. Very strange, but very stupid also. So, before the fire, Ericsson was number one. And then, after the fire, Nokia. That's number one in the world market. So there you can see the difference. So the business interruption can make that either you go out of the market or you just lose tempo or whatever. It's very interesting. It's very important to have the correct description.
Ini sangat menarik tadi dijelaskan ya. Jadi ini tantangan daripada sekarang ini adalah yaitu tadi adalah tinggi dan semakin tinggi dan semakin besar storage ya. Termasuk bahan-bahan sekarang itu dulu mungkin kayu, besi kan agak susah bakar. Sekarang berkembang ke plastik, banyak barang-barang itu udah bentuk plastik atau kertas yang mudah dibakar. Lalu ini juga arrangement flexibility. Jadi tempat semakin sempit yang harus digeser-geser. Lalu ada satu contoh dulu Ericsson sebelumnya ada bangun pabrik di mana Tyco adanya ya. Mereka nggak punya sprinkler, begitu kebakar sampai mereka punya bisnis stop, bangun lagi. Akhirnya mereka desain Nokia jadi mengambil alih marketnya gara-gara hanya kebakar. Memang mereka punya asuransi dibayar, tapi mereka harus tunggu lagi, bangun lagi, misalnya marketnya diambil orang. Nah ini yang banyak orang nggak menyadari. Nggak apa-apa, saya punya asuransi kok, biarin aja. Nah mereka nggak menyadari bahwa begitu kebakar mereka harus start lagi, waktunya harus membangun lagi, itu yang terbuang. Nah ini yang makanya kenapa mereka harus dilengkapi dengan alat pemadam.
So yeah, of course, if you don't have the correct sprinkler design, you may have increasing insurance premiums, and that can be very costly for you. At least for the international company. I don't know how it works here in Asia for the local property owners, where they have their warehouse. But sometimes I don't think maybe some of them is not insured at all. But that's where we in the sprinkler market need to change their attitude to think that if they will have a big fire, they will lose a lot of value in the goods.
I just highlight to them about this issue.
It's very important for.
Kalau bicara ke customer juga untuk salesnya, itu juga untuk meyakinkan customer yang bisnis ini. kalau nggak pakai spesial. Tapi kalau ada sprinkler ini, lebih bagus.
Okay. Next one. I will talk about the commodity classes according to NFPA. So on the left axle you have fire load, and then you on the horizontal axle you have commodity classes. So I will start on the left side of the green dashed line, where we don't have so much fire load, and what the classes is defined according to NFPA. So on the left side we have class 1 to 4 according to NFPA. So class 1, it's more or less no combustible material at all. You have some wooden pallets with metal scrap inside that. Maybe some carbon on it, but nothing really we can burn. Next one, it's commodity classes.
Ya. Yang bawah ini adalah grafik apa ya, commodity class ya. Jadi commodity class itu masih material bahan-bahan. Kalau kelas 1 itu tidak ada combustible, jadi masih tidak ada cairan bensin atau apa. Itu paling yang ada kayu besi aja kelas 1. Nah, kelas 2 ada sedikit.
Yeah, it has small amount of combustible material. And then when you come to class 3, now you see that it's a little bit on the right side of the green dashed line. That means that we have some plastic on it. So now we start. Yeah, group C or B or A plastics. They have different plastics commodities. How they define that? That they can only be less than 5% of this. Otherwise, you will go to the other side. Then you go for class 4. So in class 4, you can have only group A plastics, and then you can have 25% of the volume maximum. You call it class 4. Or 15%, maximum 15% of the weight. And then you can see, now we are going more and more to the right side of the green dashed line. So this is what happens. We go over to the plastic side. Now we see there the fire load is really going up. Before it was moderate. Now we start to go into the plastic. So. And we have different group of plastic. We have group A plastic, where you have cartoon, unexpanded.